Okay, hi everyone. Welcome to the next session. Today's session is all about this string 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 matrix problem. So let me explain the problem, and then we'll see any questions are there. Okay. So given a character matrix and a string, so there are two inputs. One is character matrix and a string. Write an algorithm to check if you find the given string in the matrix as a path in any direction. So by looking at the examples, we can easily say, right, like this is the given matrix, and the quotations here A, B, C, D is the given string. So we need to find, is there any path for this? So you can go left, right, up and down, all directions, right? I don't think only the diagonal direction is not allowed, but you can go all different directions. Okay. So if we look at here, A, B, C, B, right? A, B is there, C is there also there, but there is no B afterwards, right? But the only thing is you cannot visit the same character twice. That is the condition, because A, B, C are there. You cannot go back and say there is a B because B already visited, right? So you need to find another B. We don't have anything. We have E here and C here, and that's it. You can't go any other direction, right? So that's why it is false. And let's look at the BCCED, right? B, C, and C you can go down, and another E, another D here. So we have that. You guys can see my mouse, right? So I'm trying to show.
Yeah,
So that way you have that path is there. So it's single character also, that you can just say a, it is there. You can start with a. There are a couple of a's here, so there is a path. If you say z, or let's say k, there is no k in the matrix, you can simply return false. And this big path is also exist. So a, b, c, e, s, I think it is like a, b, c, e, s, c, f, s, and a, right, d, e, e. So it's a completely like visiting all the nodes once. So that's true. So how to find that? Let's think about this problem. Is another, and this is not in my real opinion, this is not an easy question for the interview. To be frank, even the people who tried, who practiced multiple times, let's say even you practice 10 times before the interview, just 1 hour before the interview, there is a possibility that we can't write properly. This is such a tricky algorithm, but there are a lot of things we can learn out of this algorithm. That is the reason I selected this. The reason is this is a recursive. The recursion, I already giving some examples here. I'm already giving solutions. This is a recursive problem. That means recursion is a topic, right? We can learn about it, and we can also learn the depth first search approach. This is another approach which comes into the when you practice graphs and trees. These are the things. Depth first approach is a very important topic that we will discuss. So now in the matrix itself, we are discussing this depth first search approach thing. We can think of this as a graph. So matrix can be matrix. I'm saying like graph can be represented in multiple ways. So graph can be represented as a matrix as well. So you can think of this as a matrix. You can think of this as a graph too. You can simply say A, B, C, D, E, all these are cities. Just assume that this is a map, and these are the cities. So you can go from A to B, A to S, and B to F, but there is no path from city A to F. There is no diagonal path. Assume that this is the map where you can go only left, right, up, down. Right? These are the only four directions available. So you can think of this as a map or a graph. So definitely, whenever you see it is a graph, definitely there is a depth first search, and also another one is breadth first search. BFS, DFS, very important topics. Those will be available. So this, in order to solve this problem, there are these are the two things uncovers, like how to write the recursive functions, how to think in a depth search manner. It really helpful for thought process when you go to the graphs problems. That's why I chose this problem. So any questions on this question, or are we good to start thinking about the solution?
Yeah, you can continue, Suresh.
Yeah. So
Got it.
yeah. So there are two inputs, right? One is the matrix and another one is the string. So how to start it? What are the solutions? Who want to share? Dippy, you want to start the discussing about the solution you want to propose?
Sure.
Yeah.
Um, yeah. I mean, I don't have errors in my code, but there is something going on with recursion that I need to debug. But I
Mm.
can definitely walk through, the code. Maybe you guys can spot something right
Oh,
away.
yeah.
So I will share my screen here.
Oh, you want to share? Okay. If you want to share, I don't.
Oh, I don't know. Will
That's
it
fine.
create
That's
an
fine.
issue?
Let me share. Yeah, you can share. Let's see because the recording stopped last time, but I don't think that will happen this time.
Okay.
Let's try. So I stopped sharing.
Okay.
Um, yeah, you share it. Okay.
Can you see it?
Yeah, I can. Yeah, just a minute. I have to get my water bottle.
Hmm.
Okay. Yeah, I'm ready. So
All
yeah,
right.
go ahead.
So yeah, I mean, before starting with this particular solution, Suresh, continuing from where you left, right? This
Mhm.
is the solution I coded here is a DFS, but in general, this question can be solved either way, right? BFS or DFS.
Yeah.
And also, this question doesn't talk about any constraints around you have to find it in the smallest number of steps and all of that. So I think that way either of the algorithms would work. But if it was a question about find if a path exists and find the shortest path or something like that, then I think BFS would have been a better solution. But anyways, just that was just a high level kind of a thought process there. Um, so in this one here, I start with this, right? I have this character matrix, and then I am looking for this string here, and then I create this function, right? Check if string exists.
Mm-hmm.
Here, essentially, the idea is twofold, right? One is sort of like doing a depth first approach, but in doing that, we have to make sure that uh, we keep track of the visited nodes. That's one.
Mm-hmm.
Uh, and the second thing is anytime I land on a path, go back to this one. So let's say I'm looking at this A, B, C, C, E. So, and I'm exploring this one, right? A, B. And let's say from B, I can go to either, right. Like if I consider all four directions, right? I
Yeah.
cannot go to top because it's out of boundary.
Yes.
So I'm doing that validation check there. And the second thing is I cannot go from B to A, right? It's kind of the visited node for the
Yes.
current path I'm exploring. So that's where I need that visited set sort of idea.
Mm.
And the other thing is third part is from A to B, and then from B, if I go to F, right?
Mm.
That kind of breaks the pattern that I'm looking for. I'm looking for A, B, C,
Yeah.
right? As the next. So when I land at F, I just need to basically return false. And
Mm.
also I'm deleting all these visited nodes from my current path, right? A,
Yeah.
B, F, right? And then I'm starting sort of the
Do you
uh,
need to start from beginning again? Because
actually
yeah,
that is what I might be doing wrong because I just need to start from B, right? Like the
yeah,
question, right?
because the
Yeah,
AB, let's say AB, two characters you
correct,
already visited. So
correct,
it's a
correct.
matter of checking other direction because you went
Yes,
down.
yes,
Unfortunately, we took a decision of going down and we encountered F, which is not a
correct.
good decision. But then let's revert back and
I
see.
think that backtracking, yeah, exactly. I think the backtracking logic I'm following might have a
Yes,
bug. That is why I'm running into issue.
I see.
But
But
yeah,
how you keep tracking of what the nodes you visited? What is the
yeah. So for that, I've just created a list here. Where is it?
list?
Uh, Here,
Mm.
right? So I
Mm.
just created a list of nodes. So to make it even more clear, right, I created this class node to represent my current position in the matrix, right,
I
in the
see.
graph. So I'm saying, let's say I'm in 0, 0 or whichever
Hmm.
position. And then I'm adding those nodes in my visited this list here,
Right.
right?
But how do you, okay, visitor list? Oh, in the visitor list node, oh, the node will represent what X and Y. I see. I see.
Yeah,
The indices will be represented there.
right, right. So
But
this
in
is,
not how do you find? Let's say you completed AB and you
yeah,
want to go for F. How do you
right.
know whether F is there or not? You have to reiterate through every item in the list to figure out.
Yeah, I mean, yeah, right now that is like if I start looking at complexity level, there
Ah,
is room for optimizing this. But
yes.
as of now, in terms of picking a data structure which will serve my purpose, right?
Yeah.
I started with list.
So,
Um,
what is the best data structure just to solve that problem? Because first we are considering you are putting every node that you visited in a list. Okay. So let's
yes.
start exploring that problem. So every time, let's say you want to go to the next node, and you need to know whether that node is already visited or not.
I mean, in general, I can use a hash set or something, right? It's
Hash is also a good option, but what is the key and value? Let's say we want to store both x and y.
Yeah,
Um,
so if I'm storing x and y as a node object, right? Then
I
I'm not looking at it as two things. It's a node object. So
mm,
in my hash set, I'll just store those nodes.
mm.
And then I just check, right, if that exists on my current path or not.
So
That is
basically,
like,
the key is the combined key with I and j, both x and y or whatever it is. The rows and column index is a key.
uh-huh. Well, I'm talking about set, right? So in this case, I don't have to, it's not a map I'm thinking.
Yeah, but set has a problem of iterating everything. You can't figure out. Let's say it has 1,000 elements. Let's just
Uh-huh.
assume the matrix itself is a big matrix, and you keep on putting in this node list, and
Yes.
identifying whether a particular node visited or not is a very complex task of figuring out. You need to traverse all the nodes and find out.
No, why so? It's a hash set, right? So if I
Oh, hash.
compare,
Yeah. Mhm.
right? So if I do like a override here, I define that hash code method,
That's
right?
what I'm saying exactly. Yeah, you need to
Yeah.
override the hash code.
Yeah.
It will say, "Oh, it's there." Then it's order of one. Yeah,
Right.
yeah.
Right. Right.
So
So since I didn't go that route in this case, so
yeah,
that's why you don't see that method. But if I'm doing it, I'll just override that hash
yeah.
code
So I
stuff.
will give
And
you a hint here, not hint actually. I will give you the very good kind of practice, or what we call
Mhm.
best practice in terms of solving this. There are a lot of problems where this matrix and path
Yes.
traversing. With the matrix path traversing, matrix is a very beautiful thing about matrix is we know the bounds. It's not a graph, it's not a
Right.
tree.
Right.
We know the bounds. So Tarun, are you following so far? So basically, whenever we are
Yes, Suresh.
creating a matrix, if we want to keep track of the nodes, rather than these are, it's not a bad idea to use list or hash map, as you said.
Uh-huh.
Those are good suggestions, but the very best practice that many of the algorithms use is simply another matrix because you know the bounds. So if you go scroll up a little bit, show me the
Mhm.
matrix you have, how many rows and columns you have. Two rows and four columns, right?
Right.
So at any point you don't go beyond those. You have just eight,
Right.
exactly eight nodes, right? So the best approach in many of the algorithms is just take another matrix of the same size, okay, with the boolean values, true or
Mhm.
false. All uh, initializing the entire matrix with false, and
Right.
whenever you are visiting the particular, let's say you started visiting with C or B. Let's say you started at B, the exact location in the other matrix you
Yes.
made it as a true.
True.
That way, because the indices of B is exactly the same, zero, it will be 0 and 1, right? You simply go 0 and 1, you can check whether true or false. Let's say after B you're going down F, right? Now that what is the index of F? It is 1 and 1, correct? You go directly to the other matrix, see is it true or false. 1 and 1, give me the, it's kind of checked matrix or path checking matrix. Let's say path checking matrix of 1 and 1, is it true or false? If it is false, you can happily go to the F, from B to F. If it is true, you're not allowed to visit F because it was already visited. You guys following so far?
I'm following it, but my question is, what is the, like, if I think about it, right?
Mm.
Comparing it with hash set, right? Hash approach. That
Yes.
hash one is also order of one.
Yes.
This one you are describing is also like order of one, right? You directly go to that index in that
Yes.
matrix and you find out whether it's visited or not. So
Yes.
that way, to me, it sounds like complexity wise, it's the same. But
Yes.
the downside here I see is, if you think about when you're exploring a certain path,
Yeah.
right? Let's say it's a big matrix, and
Yes.
right now you are on A, B, and somewhere down the
Yeah.
matrix. Let's say you have overall. Imagine if we have million
Mm.
nodes in the
Mm.
matrix, and in our current path we are at, let's say, 10K,
Yeah.
right?
Yeah.
Nodes. Now with the approach that the other matrix approach we are talking about,
Mm.
that is going to take additional 1,000 node space for
Exactly.
sure.
It is exactly take the same space as the
Same
input.
space, right?
As input.
Whereas the hash node is more like whatever is the longest path that you can go,
Right.
down the matrix.
Yes.
So isn't that one that way, at least space wise, better?
Yeah, definitely. I think what you said is valid point. I totally agree with you.
Uh-huh.
But the coding wise or maybe implementation wise, it could be little
Or more
challenging. So,
cleaner.
but yeah, but it is good idea. So it's not bad using that hash
Sure,
function.
sure.
But the
Yeah.
problem is, I don't know how you write the hash function that will yield the uniqueness. So,
Mhm.
yeah. So of course, I haven't practiced much on the hash functions and hash tables. I know hash table, hash set, but writing our own hash function that can yield a
Yeah. Yeah.
unique index is very important. So,
Mhm.
but those are the things, but make it out simple, like using a matrix. Another matrix is pretty common approach
Yeah.
that I saw in multiple problems, not only this problem, a lot of matrix related problems where we use another boolean array or ones and zeros array, kind of
Mhm.
integer array or boolean arrays. In I saw
Yeah.
many solutions. Okay. So, okay, whatever it is, we are going to use another data structure
Right.
that will help us to indicate,
Track the visited nodes
yeah,
and the,
which
yeah.
which nodes are visited. Okay, now what is the next solution now, from?
So yeah, so basically the way I'm going is I start with this function. I define, since I can go in four directions, right? I
Yes.
say that, okay, this is how I'm defining my rows array. So this is saying if I go up, then I'm decrementing my row, right? If I go down, then I'm adding, to my row index. Basically, these are like row indexes, whether I'm subtracting one, adding one. If I'm moving left or right, then my row index is not changing, right? So that's what zero is. And
Oh,
similarly for
okay.
columns.
Interesting. This is
So
interesting solution. You take another two arrays, small
yeah,
arrays.
yeah.
Okay.
So, and then I said, okay, I defined this one data structure. And then the point is now I start calling this recursive method, right?
Mhm.
I just go through my matrix and I call this DFS. And the main logic is here, right? So I try to check that if my current position at the matrix is matches my first character of the string, right? Because I want
Yeah.
that. So if I'm looking at this one here, I'm
Mm.
checking this A
Yes.
against the first position, right? So if this matches, right? So I am on the correct path. If it doesn't match, just return false here. If it matches, then I add that to my visited list, right?
Okay.
That node.
Yeah.
And now, and this is another base condition, right? If I'm at the end of the word,
Ex-
then I have found the path, right?
Exactly.
Basically. Now this is where I'm using my rows and column index array, that 0, 1 thing I have defined. So
Mm.
from my current node, right, I can go in four directions, right? So I pick, like I do a loop here,
Yes.
which is traverses all four directions. So
Mm.
I say, okay, pick the first one, right? Here I'm going like top first,
Very good.
right? So yeah, so here, right? So I'm decrementing a row, right? But the column remains the same. So I'm moving top here. Um, this is my next position.
And
But basically, what I do is first I try, right, if this is a valid position or not. And I think this is where I'm kind of, I
mm.
need to revise my code. There is something I need to debug this. because the idea is that I am at a current position. I know that is the correct thing because I have checked this one here, right? This path. So
Yeah.
I know my current node is on the right path. Now I'm checking my next node. I'm basically defining my next node, next position, which in this case, if you think about it, right, taking a walkthrough of this example. So
Mm.
I am at A here, right? And that matches the first character of the given string. So
Yeah.
that's fine. Now I'm saying move to the one row above, and there is no row above, right? This is the topmost row. So if I look at my is valid code, right? So
Yeah.
this call here basically should return, actually, they should be like,
False.
they should return false,
Yeah.
right? So if I look at my is valid code, I'm checking like boundary conditions, right?
Is
Uh,
valid. I see. This is a separate function. You put it there.
Separate function. And I said it should also, my current node should not be on the visited path.
I see. I see.
Um,
So why you like? Let's show me the rows and columns matrix. The one you
uh,
initialized. The one
oh,
you initialized on the top.
yeah.
And why you took -1 1 0 0? What is the rationale
So
here?
here the idea is these are the increments or decrements I'm doing with respect to my current row, right? So if you look at, let's say, this one here where I'm using this, so
Mm.
I'm saying whatever is my current position, current row index, n dot x,
Mm.
right? To that add where the direction basically. So if I'm saying row 0 here, right, k is 0, then I'm adding basically -1. So I'm moving up.
G -1. Oh, yeah, adding -1 means decrementing. Okay.
Decrementing, right? So I'm moving one up, right?
Then
And
why
then,
it is one for the second one? Yeah. Yeah.
yeah, so it's like +1, right? Whatever is the row index I am at, add one to it.
That
So
means
these are
going
all like
going
sort of,
down.
yeah,
Okay.
yeah.
Yeah. And
And
then
then
going
left and
right.
right.
Okay. Left and right 0 0.
My row index won't change, right? If I go left or right.
Yes. But for which node you are referring to? That -1 1,
Uh,
from which node to which node? Because every node,
so,
let's say if you go to the input matrix, go to the
yeah,
input matrix on the top, every node has maximum 4 directions. Take any,
right,
let's say if you take A, right?
correct.
There is no node top, there is no left node, there is
Yes,
no top node, but there is a still right node and
yes,
down node.
yes,
Similarly, let's take F. F
yes,
also have all 4 directions, but only 3 nodes are valid. S, B, C. There is no
yes,
node below F.
yes.
So every node there are 4 possibilities.
Yes, and
So
that is what I'm doing here, right? So I define my
mm,
rows and column possible. I should rename it to like direction indexes.
I
So
see.
these are just size 4, right? Because there
Okay.
are
Are
four
you
possible.
modifying this or no? Are you
What?
modifying this rows column and
No,
rows?
no, I'm not modifying this one, but I'm modifying basically how
Mm,
I'm accessing, right? So these are four directions I can go,
I
and
see.
this is defined by the length of my rows matrix, right?
Okay.
So, and then I'm just exploring all four directions.
Interesting.
So, yeah.
Okay.
So, and then I'm saying, like I was showing an example, right? So
Yeah.
I have validated that A is my correct, I am on the correct path. From A, I can go now. What are the next possible ways I can go, right? So I define it here. So in this case, if we take step by step, here I'm saying from A, I'm adding row 0. Row 0 is -1, right?
Yeah.
So I'm trying to go up, and column 0 is 0, right? I am not changing column.
Yeah.
So now that is not a valid position. So it calls this is valid method, right? On my this new coordinate, and then it should return false, right? And
Yeah.
then I don't even like do this call, right? It's not, it's out of bounds.
Yes.
Now, imagine a case where now let's say I'm exploring, in this case, bottom, right?
Mm-hmm.
Uh, so I add one to my current index, right, which is this. My column remains the same.
Mm-hmm.
And now it is valid, right? So it's not like a problem. S is not a visited node and it's not out of bound.
Yeah. Yeah.
Then I land here. So now I'm checking that At this point, this should return false because when I call this method, this condition fails, right?
Yes. Yeah.
So, and but there is, I need to kind of step through it because
Yes.
it's
Yeah.
not.
There could be another direction that exists. Instead of just returning there, you need to return
No, no,
false.
but that no,
This
but that
means
is what no, no, but that is taken care of. That is not a problem because
yeah.
once it returns false from here, it's
Hmm.
a loop, right?
Yes.
So then I check the next direction. But I
Yes.
think something is I need to check here. This is where I'm backtracking,
Okay.
right? If I have checked all four directions, let's say
Hmm.
things are not making sense. This is where I'm getting confused. I'm not sure if this
That
is.
yeah, that's fine. I think this is also good algorithm, but definitely there will be a ways to solve this. But it's very good efforts. These are the efforts really helps you to think and helps you to understand the actual solution as well. Right? Very good. Okay. So can I share
Yeah, yeah.
the actual solution that was provided in the book?
Oh, sure.
To be frank, you did a great job of exploring yourself. But when I practiced this problem, I just looked at the solution,
Yeah, yeah.
understood how they are solving it. So,
Right.
but even looking at the solution, if you open the book and if you look at the solution,
Uh-huh.
it will take a lot of time to understand, right?
Yeah.
So that's what I'm trying to help here. Tarun, I'm going to share the screen now and show you. Tarun, did you get a chance to explore the what is the DFS, how the DFS works, and all those things? I want to give a little
Yes,
bit
Suresh.
intro. Oh, you already explored the DFS. Very good.
Yeah.
Yeah. So let me start sharing again. So yeah, so let me go back to the little intro about the DFS. Even if you know, I just want to make sure you understood. So DFS means yeah, I want to hear from Taran what he knows. What is DFS? Let's say um, depth first search, right? So how it works?
Yes.
Yeah,
It's
explain.
considered depth as
Consider what?
depth
Yeah.
of tree.
Yeah, what is meant by that? Like in this example, use this example. That those are the numbers, or just give me how this depth first search work. What is depth first search? Okay, I will explain. Okay, is that fine? Should I go ahead?
Okay.
Yeah.
Okay.
So depth first search. Why we are using depth first search here is we are blindly just imagine we are going to find this string. Can you give me one of the inputs that we want to find? We want to find, let's say, ABBACCED, right? ACCED. This is one string, and another one is ABCB. ABCB. Okay. So now let's talk about the general thing. So what is the value for this? Is it true or false? ACCED. Do we have this?
This is
False.
false, right? False.
Yeah. So ACCED. Oh, BCCED. Sorry, I said A here. Let's say BCCED. Is it true or false?
True.
B
It
C
is
E
true.
T. So you found you visited BCCED, right? It is true. Now ABCD. ABCD. True or false? Is it true or
False.
false, right? Because you start with A and B, C. You ended at C, and we said false because there is no F from here. Of course, you cannot go like this, right? You cannot go in this direction. That is not allowed. Only up and down. So A, B, C visited A, B, C, and then you stopped. Now let me answer. Let me give you one more example. Um, um, F, C, S. True or false?
True.
Okay. Is it true, Dippy?
I'm sorry, which one? FCS?
FCF. FCS.
F- FCS is true, right?
True, right? So
But we can't.
FCS. We found these three values, right? So what we are doing, basically, our eyes are already at the F. Our because you can see the F. Oh, we start with F. But behind the scenes, our brain already processed A, B, C, E, S. You already ignored all these characters, isn't it? Behind the scenes, because you know there is F there, but behind the scenes our mind already rejected ABCABCABCE, and our mind already checked ABCE. Okay, CE, you already checked all those things, and finally you said, okay, this is not going to work because we want to start with F, and you rejected ABCES, and now F is the one where you started, right? So starting point, basically, first thing we need to learn before even coming to the DFS, I want to explain what is the solution. First, the solution our mind is doing is, where is the first character, right? You always start with A, you always go with B. Basically, you iterate every character, and if it matches with this letter, then you start exploring. That's the first thing, right? So so we have to scan the entire matrix for sure. That's one thing, right? Once you find a matching character, then you go all the directions, isn't it? Now DFS comes into picture, depth first search. What it meant by this is, we will explore one path. Okay, let's say you found F. Okay, you choose to go the right side, and you found FC. Oh, it's matching our string, very good. Let's go in the same direction, FCS. Let's say if you have something like K here, then you reverted. Oh no, S is not the right direction. Let's revert back. Don't take S. Let's see another direction. From C, what is the different directions? Right, top, and bottom. Let's go with the top. F C C. This is C, which is not matching our K. Oh no, this is the wrong. Let's go down and see. F C E, right? You explored all the paths. Basically, you go down. Depth first search means you go down all the way to the depth of it and checking it. If you did not find, then you go upwards. Basically, you revert back. Depth first means you will choose one direction blindly and go until you find the false. Every time if you find the false, you come back to the just before the position where it was true. So F is true and C is also true. Now from C you are going all the depth. There are three ways you can go, because you came from this direction from F. From C you can go, there are three paths. You can go up, right, down, isn't it? So you're going in a depth manner. You haven't visited the other ways from F. That's what I'm trying to say. Differentiation is like, you already you already started, going in one direction from F. You gone to C. You did not We did not look at FD yet. We did not look at FB yet, right? The F also has four directions, isn't it? Are you guys following? F also has four directions, but we already chose
Yeah.
one direction and going in the same direction. That means depth. You want to see the depth of it. That's what depth first search. Okay, so now there is no way. If there is no way you can explore with C, then you revert back. But now with the C, we C is F is true and C is also true. Now from the F and C we have good relation. We have matching characters. Now what about the next character? That's what we do. So we explored all the three directions. If we did not find K, then we simply say C is not a right candidate, because we want to find FCK. We found FC. FC is good, but there is no K from any of the three directions, right? And then we decide C is also false. It's not a good idea to take the C. This C, whatever we are looking at, there is a C after F, right? That C, until now we are assuming this is good to take that C. because we are assuming there will be k on the top or left or somewhere we'll find the k, but we did not find the k in any of the directions, and then we mark c also not a good candidate to take it. Got it? So the idea here is, go ahead. Any questions, Tarun?
No, sorry. Got it.
So we are trying to explore. At the same time, we want to back out if there is no path forward. Okay. So what I'm trying to say here is how to solve this. DP, are you following so far? Right? Any questions?
Yeah, yeah. No, this is good.
Now we want to use the another, as I said in the beginning, this rather than using the list or the hash table. Those are also good examples, but to make ourselves little comfortable, what we do is we will take the exact same um, size boolean matrix. Okay, we will take the exact same boolean matrix. Now let's always talk about this example, because this could be the better example to talk. FCK, because these are also good examples, but little bigger examples, the one we have here. Let's see, FCK is the one we want to find. So as always we have to start with the topmost, in a general iteration of the matrix, right? Always from the 0 0, and you go all the elements. So FCK is our string. So what we do is, and just a simple two for loops, always, right? If you want to traverse the matrix, we will write two loops, isn't it? Because you start with a b c e and start with s f, so rows and columns. So simply start with that. But we need to think about this. You are starting at a, okay, then that means you are starting fresh. That means all the matrix we need to set as false. Now a, there is no way you can get, there is, it's f, we want f. So now again start with b. Now again you set the matrix to false. Let's say you have f somewhere here. Let's make our fck, right? Our example make more sense. Let's say f is here, another f is here, but here fck is not there. But we don't know, there could be, when you traversed a, we know a did not match with f. When you started with b did not match with f. Simply now you want to start with f, right? So again, you marked everything as false here, false, false, and false, everything false. Now let me put f here. So now you encountered f here. Oh, really nice. We got the f. So what we do is we will make this as true, right? This is true. From here, you start the depth first search, because you found one element, right? You found an element and you mark as true. Now you find you're going to traverse all different directions, because you're done with f. Let's see if you find c, right? That's the next part. So when you want to navigate with the c, we need to mark that as true, because f is already marked. The previous character should be marked as true. Now you started with f already, we found. Now you want to find c in all the directions from f. Okay, now the first for loop is still there. That um, uh, starting of the searches, that loops are still there. Now you are in a different method or a different algorithm, because you found one character, right? Now you need to find the different paths, all the different paths, right? So from f you can go to e, which is not matching c. Okay, now from f, if you go down, you found c, right? Then what we do is the same. Just think about the recursive here. You found another character, again you do the same thing. That means, okay, let's mark that character, the value of that position as true. And now we need to find rest of the string in the same matrix, isn't it? So it's a repeating process. So you mark f as true, in the position character in the true false character matrix, and you also marked C as true. Now from C you need to find K in all the directions. From C in all the directions, but from C you should not go to the top because that is already marked as true. From C you can go left, you can go right, you can go down. So these are the three characters you can go and search for K, right? So because they are false here, that's another thing. You need to go only if that is false. So here we did not find K, here we did not find K, here even down we did not find K, right? Now now what we need to do is, we cannot consider C. We want FCK, right? There will be something like let's say FC, this is also C and this is K, right? Just assume that this E is C and the S is K. Then there is FCK from here, from this, right? So that's why there could be a possibility that F is still valid. We don't know yet, right? We cannot mark. What we need to do is, since C is not a right candidate, this particular C we need to revert back to F, false here. Okay, we are reverting back the value to false because it is not a valid position that we can consider. Now we need to see, okay, again we need to search for the C. That is the problem here. Even though you found C, now it's not value. There is no value of taking this particular C. We need to see from F in all the directions. We only visited down, right? From F, from the first F here, we visited only down. What are the other directions? We can go from F, you can go right, you can go
Right.
left, isn't it? In the left we have B here, on the right we have E. Of course those are not valid characters that we want, but we need to explore those things. Again, we found E here, which is not what we want, and we found B here, which is not what we want. Finally there is no more paths from F. This particular F, you already visited all three directions, you did not find C, so you are finally marking this F also false, because there is no point of taking this particular F for our solution. Again, what happens? Now we are reverted back to the again. We need to start from the scratch. We need to start from FCK. Again, we need to start finding FCK. But where do you start? You start from this character, because you done with A, you done with B, you done with F, you done with 0 0. What I'm saying is, you done with 0 0, you done with 0 1, you done with 0 2. Now you need to take 0 3, isn't it? It's outer for loop. Basically, you started exploring from A, you done. You started exploring from B, done. You did not find. Even you started exploring with this first F, which is which is a failure. You did not find FCK. Now you explore with E, which is also E did not match with F. Done. Now S. No. Now again you got the another F, right? Which is matching with this. Now start explore. Start explore. You found F. That means immediately again you follow the same process. Make that value as true. Okay. Now let's find the rest of the characters CK in the same matrix, right? Starting from that node, starting from F. What are the different directions from F? Again, F has all four directions, right? You can go top, you can go left, you can go right, you can go down, right? Are you guys following so far?
Yeah, Suresh.
So basically, there are different loops here. First one is outer loop is the starting position. Outer loop, outer for loops. There are two loops where you iterate through rows and columns and find the starting position. Once you find the starting position, then and mark that position in the true false matrix, and then explore from there. Explode. Basically, you found a starting point, and from there, let's go all the directions. But before that, make sure the matrix is set to false, because you're done with the ABFE on the top. If you are exploring with a new character, you make sure that matrix is all false, because you are starting your search again, right? But from f, right, when you start with the second f, you mark that as true, and then you need to search for ck. You always check with the matrix what are the nodes you already visited. So f is there, which is you marked as true. Now from f, I'm just changing the color, let's say pink. So f is there. Now you want to start with c. Okay, so f and f, there is different directions. You can go to the top, b. If I go left side, yes, is d here, and c here. Let you just started exploring left side. You can explore any of these. This is a depth first search. You can go depth in any direction. There is no fixed thing that you always start, go right, go top. You can go anywhere. Let's say you choose left side. Okay, you started exploring left side, and you found s which is not matching c. Simply you stop exploring left side, you go to the top side, and you found b which is also not matching, and d which is also not matching. Now finally c, which is a matching thing. So now what we need to do is we need to mark that as so true here. Now the problem becomes iterative. Again, starting from C, you need to go all the directions except left. Of course, you can go left and C, but this F is already marked as true. Don't consider that F, right? So F is already marked as true. This C also marked as true. And now from C, we are looking for the substring K. From F, we are looking for the substring CK. If the problem becomes smaller, initially the problem is you need to find FCK. Since you already found F, you are just need to find CK, only substring. Now you already found C, right? You found F, you found C. Now the problem is you need to just find the substring which is K. Of course, right now only one character. Let's say FCKL, just example. Then KL. So whatever the remaining string. So now the problem becomes smaller. That's why it is called the iterative problem or recursive problem. The problem is the same problem you are solving from different locations. From first time you're looking for FCK. You found F. Now you're looking for CK. C found. Okay, you are looking for K. It's the same problem you are repeating, but same problem you are repeating. Now C, you need to find K. C, you can go top. If you go top, you will see F here. If you go right, you can find S here. If you go down, you found E here, right? So you start exploring. Is it K? No. Is it K? Is it K? So finally, there is no K in any of the directions. Now you revert back. So the choice of taking C, this C is not right. That means you need to revert back to the F again. And before doing that, we need to make sure this as false. Now you came back to the position F. We need to see, do we have any other paths that we explored? We already explored S, we explored B, we explored D, we explored C. We found, unfortunately, we did not get true from that path. So finally you return false. But assume that just at the same time, I want to make the input little bit smaller to understand. Now it is FCS. If it is FCS, right, you found a path here when you are at this location. So for C it is, for F it is true, for C also true. Now from C you go top, you found a false. You go down, you found a false, because you want to find S. Instead of K, I changed the input to S. So if you go top and bottom, you did not find. But now if you go to the right, you found the S. You found the S. Now the problem is there. Still the recursive problem will go there. Now mark the position of S to true. Okay, now position of S to true. Now find the next character. What is the next character? So the input is F, C, S. You found F, you found C, you found S. Now you want to see, do we have any other character left that we need to find? Do we have any other character? No, right? We found all the character. That means you can also do one thing. So simply you can have a counter of how many characters you found. So another counter. Let's say you found one character, two character, three characters found, and the length of the given input is 3 minus 1. Yeah, basically what is the length? So it's of three characters. So whenever,
Wait.
yeah, the counter, let's say the counter is 1 here. When the f was found, the counter is 1. When you find c, the counter is 2. When you find s, the counter is 3. So whenever that counter matches the length of the string given, right, then you found the given string. Simply you return true in that situation. You no need to repeat that same process, right? You no need to explore from yes. You can go top, you can go down, you cannot go left side because you already visited c. The c is already visited. So there are two paths from s. You can go down, you can go up, but you no need to do that because you already found all the characters that we need. So that's the breaking point. Okay. So in this algorithm, assume that how many starting points we visited. We visited only one, two, three, four, four elements on the top, and in the second row, five, six. You started only six times. You started the algorithm six times. The DFS started only six times. You did not start from C. Yes, because you found the value, you found the actual answer, right? You so here is the answer. There could be another FCS in the matrix. We don't know. We haven't visited, right? There could be, let's say, another row here, which is FCS. There is another row. We did not we don't care. So we found FCS here, and we simply say FCS is true. You haven't visited this F, right? So
Yes.
that's what I'm saying. So this is how the algorithm works. So I know it is complicated, but by having some knowledge and how we are approaching, then if you look at the algorithm, you can understand. So Dippy, any questions or is it?
No, no, this was a good walkthrough.
Yeah. So now let me show the algorithm and explain the similar way as we visited. So this is algorithm. So here is the matrix, and simply I'm just printing the matrix here. And here are the different functional test cases, like searching for this string and this string. These are different boundary cases. So what I'm doing here is, this is the simple algorithm. Has path matrix input string. We need to write this. Has path is the algorithm that we need to write. Simply passing the input matrix, and here is the input string. We want to find a b c b example, right? Now if this returns true or false, I'm just printing path found, path path a b c b found true or false, right? I'm just returning true or false. Now let's look at this has path. What is this has path algorithm? Okay, let's open up. Please put a full attention here so that we can understand the algorithm. So first, boundary cases. Okay, we haven't even discussed. One is, if matrix is false, matrix is null, there is no element, simply return false. If the matrix length is 0, some length is there, it's an empty matrix, either null matrix or empty matrix, there is no elements, return false. Now another thing, string is empty, the input given string is empty, you are asking me to find nothing, so simply return false. This is boundary cases. Now this is the way to find. I think every algorithm has, every language has different function. Simply we need to find how many rows and how many columns. This is the way to find in C sharp. So I don't know what languages you're practicing. If it is Java, this will be a little bit different function. It could be this, it's a slight variation. So matrix dot get length of 0 will give you the rows. Get length of 1 will give you the columns. Okay. But anyway, rows and columns. You need to find rows and columns. Now take another matrix of same size with Boolean flags. As I just explained, right? You will take another matrix of bool, same rows, same columns, and you need to initialize with false. Of course, in many of the languages right now, in the modern languages, when you initialize a Boolean matrix, it will be automatically initialized with false. Every cell will be initialized with false. Just for the sake of explanation, I am putting that. So you initialized every matrix with false. Now this is what I am talking about, the initial search. You always start with you always need to traverse all the rows, all the columns, and you need to find the string, right? This is the outer layer, this is the outer iteration. Basically just like our eyes, you our eyes already visited a b f e, and yes, we started with f because our brain already visited from a b f e. So we know that those are not right candidates. You already gone through the first row. Now we started exploring the second row, and where you found f, that's where you started the actual exploration, right? So every element, we need to start from every element all the way from top left. So what are the inputs? Here is the matrix, given matrix, and here is the indices. I am saying I am going to search for the string starting from this column. Starting, this is the row, and this is the column ij, and I'm also sending what are the number of rows and number of columns, because it's kind of boundary, right? How many rows, how many columns we have, we already calculated here. So I'm sending those two variables. Hey, this is the matrix, please start exploring the path from this row, this column, and here are the rows, here are the columns. And what we need to find, we need to find this is the input string, and use this matrix as a use this matrix as a way to indicate your visited nodes. And until now we did not find any characters, that's why we say 0. So what just trying to understand what are the inputs here. The inputs is given matrix, next one is row index, column index, how many rows we have, how many columns we have, and what is the input string. What is the input string? This is the input string. And here is the visited matrix. It will tell you the, it will give you the matrix where how many which elements are visited. So now the next one is the path length. Path length is exactly the length which I explained at the last, right? If you take the length is fcs, right? Initially when you are starting with this f, we'll say 0, we did not find anything until now. So please start from this let's say please start from this location, find input string fcs, and until now we did not find any values 0, right? Because you starting with a, you did not even compare a with f, right? You're starting with a, you want to find fcs, and we did not compare anything. That's why the input string is length, like that's what the length so far is 0. That's why we are sending 0. It's up to you. We are saying this algorithm, please search, please search for this input string starting from this index, this row index, this column index, and here is the matrix, here is the input string, here is the, we are giving everything to the algorithm. We are giving all the tools, all the things to the algorithm. Now this algorithm, what this algorithm will does is, this is the very core algorithm. We, this is where the actual thing happens, right? So as I said before, path length, if the path length equal to the input string dot length, that means input string is here. If the path length is basically how far you visited, how far you found, until now 0. But in case if the length is equal to 0, if the path length equal to, because this is a recursive function, so please note that we will call this function down the line here. That's why we have this boundary condition. Whenever you are writing a recursive function, this is the breaking point, very important to write where you need to exit. This is the exiting loop of that recursion. Whenever this path length is equal to the input string length. Input string length is, what is the input string? FCS, right? FCS. What is the length of it? Speak out. Are you guys following? What is the length of input string?
Yes.
3, right?
3.
3.
3. And what is the value right now is 0. So
Zero.
If
But Suresh, you are not incrementing the length where you are incrementing
I will
the
tell you
function.
exactly. Very good question. I will tell you. So right now, I'm just this is a breaking condition. In case you visited all three, then path length will be three. In case you visited all three, the path length will be three, and we need to find three elements, three characters. Very good. Now that means you already found a path of three characters, a valid path of three characters. So if this becomes three, that means you already visited FCS. That is the logic. It should never become three if you did not find it. That means if you find this a b, let's say fc, right? Fc is there from this f, from this f on the top you have fc is there, but fc s if you did not find, let's say excuse me, let's say um fck, if you are looking for fck, that path length will never be 3 because there is no fck. So path length will be equal to the input string whenever you find complete path. So whenever this is, that's what it is means. If these are true, means we navigated all characters of input string, means we found the full path. That's a true. I will tell you how when we are incrementing. Now what we do is, first one, has path. This is another variable. We are saying has path equal to false. Okay. Let's see what we are doing with that. Has path, that means you are exploring your, so you have given, what we have given, we have given a matrix of all false. Okay, matrix of all false in this initially, right? So oops, something happened here, it's gone. That's fine. So we have given a matrix with false. Now we are saying, sorry, need to drop add hard stuff. Okay, okay, yeah, no problem. DP, yeah, please, you can
Yeah,
watch,
sorry.
you can watch
Yeah,
the video. So you can
sure.
also go through the algorithm, no problem.
Yeah,
Okay,
yeah. Thank you. Yeah.
no problem. I see you. Yeah, Tarun. So here is the thing. So what you following, right? So what we are doing here is,
Yes, Suresh.
we are initializing a boolean value as false. Now we want to make sure you are at the right position. Row greater than or equal to 0, row less than rows, column greater than or equal to 0, column less than columns. That means you are in a position where in a right position. If the row becomes -1, right, there is no row with -1. Similarly, if the row is boundary, basically you are checking as long as the row and columns, okay, are within the matrix, right? This if condition makes sure that you are within the matrix. If in case at any point if the row becomes minus values or row becomes out of the boundaries, you don't even execute this if
Check.
condition. If condition, okay, that's the first thing. Make sure row and columns are within the boundaries, and matrix of that row and column is equal to input of path length. Matrix of row and column. That means matrix of that this particular row and column, right, is equal to the input string of path length. That means what is the path length? First we want to visit the 0, right? 0
Yeah.
means the first character. 0 means we are this path length will tell you what character you are looking. We are looking for, because we haven't started, we are looking for f. Let's say example fcs. I think my ink was gone, that inking slate,
Oh,
that was closed actually. But let's say what we are trying, what I'm trying to say is, we need to find which character we want to find, the first character. Okay, if
interesting.
the value in the matrix is equal to, the value in that particular cell is equal to the input string of path length, whatever the character you want to find, right? Let's say those are
Mhm.
matching. You want to find f, when and you are at that particular f, the location or the character in the matrix is f. If both are matching, then look at the next one. And then and the other part is that particular row and column should be unvisited. That means should be false. If it is already visited, if it is true, you don't want to take that, right?
Yeah.
So this is the thing. This is all the conditions. You should be at the right boundary, like columns and rows should be in the right position. and the value or the character in that matrix matches the